Hello and welcome to today's presentation on Azure Kubernetes Services. This presentation is only the introduction to Azure Kubernetes Services, and this is part one. And before we actually dive into this presentation and start talking about AKS, let me just explain you that why I have broken down this presentation into several videos, right? So to start with, I think most of you would agree with me that Kubernetes in general is one of the hottest topic in the modern software engineering and cloud context, right? So I don't think anybody would disagree on that thought process. And you will also know that because this is so hot, this is what the organizations are finding the value here. Either you or your organization is already deploying it, or it is in your roadmap to deploy it, or you have been asked to deploy it. Now, the reason that I have got these videos broken down into several videos is because when I started working on Azure Kubernetes services, I found it a little bit overwhelming, and to be honest, I found it confusing, as well as I had difficulty in finding all the relevant information and documentation in one single place. So my first video that you're watching is to help you to get around that, and you will get an introduction to Azure Kubernetes Services, what it is, what problem we are trying to resolve, what are the pros and cons in this video. Second part of this video, which will be part 2, again introduction to Azure Kubernetes Services, would be very basic implementation of Azure Kubernetes Services AKS cluster, deploying application, and going around the full life cycle of Azure Kubernetes Services from upgrading the application perspective and upgrading clusters and whatnot. Now, again, at this level, you are still very basic understanding of AKS, but once you are ready to deploy AKS clusters in your environment, whether it's a prod or dev or test, then you also need to look into another video that I have created, which is around AKS design consideration. What are those key elements that you and your organization should consider before you are ready to deploy and start putting your production workloads on Azure Kubernetes Services cluster? So I encourage you, after you watch these first two videos, you might want to watch Azure Kubernetes Services design consideration video. It is on my YouTube channel, so you will find that there very easily. Also, if you are going to go a further step ahead and you really want to see it in action as an advanced deployment, where you would see how you could take the advantage of AKS for microservices, I have got two videos there that would explain you how to run and how to deploy microservices on Azure Kubernetes services. So that would give you enough insight that why I have broken down it into multiple videos. And secondly, I also want to ensure you that once you go into the design consideration video, many of the elements that I have described in that design consideration, I would be coming out with the videos for each specific section and relevant section around it in next few weeks or few months, right? So please stay tuned on that if you are continuing working on AKS. With that, let's move into the agenda here. And what I have done here is, as you will see, it's very simple. Before you actually go to the Azure Kubernetes services, you should be fully acquainted with what the container technology is, what the benefits, what the pros, and what the cons of the container technology is. So in next few minutes, we will be only talking about giving you a brief understanding of what the container technology is, so that you could understand Azure Kubernetes services better, right? So that would be the second part. After you understood that why container technology is so important and so hot, then you will go into the Azure Kubernetes Services introduction, which is the sole theme of this video. And once you have a good understanding of Azure Kubernetes Services, again, this is very basic. This is not advanced. You know what Azure Kubernetes Services are, what container technology are. Then I would walk you into a demo, which is the part 2 video, where you would go through and deploy a very basic fundamental AKS cluster. You will deploy application into registry. You will deploy an AKS cluster, deploy application, scale application, update application, and upgrade an AKS cluster, right? If you're not familiar with all these terminologies here, don't worry about it. We'll be talking it in length in next few slides, but it gives you the flavor, right? And by going into these two videos, part 1 and part 2, I would not say that you would be a you would have all the required information to have a successful AKS implementation, but at least you would have a starting point, right? I'm not trying to sugarcoat it. It's not that easy. There are a lot of elements that you need to consider, but this is the step by approach to go around AKS. In my viewpoint, you may agree or disagree with me, but once you get to these two videos, then you can start looking into the design consideration video, as I mentioned earlier, and also see by microservices deployment on AKS. And hopefully by the time you finish these sessions or these presentations, I may have additional videos created for each of the element that I have talked about. With that, let's get into the container technology.
And when we talk about container technology, excuse me, what I have done in this particular slide, that I have two separate boxes. On one is talking about traditional approach of the virtual machines, and the second box on the left is talking about a new modern software engineering, new process, new approach, which is a containerized application. And the goal of this slide is to distinguish these two approaches, understand the advantage and disadvantage of each approach, so that we can move forward and start understanding some deeper part of container technology as well as Kubernetes services, right? So let's start with the traditional approach of deploying your application through virtual machines, whether it's an on-prem environment or whether you are using a cloud services and IaaS. But traditionally, what we have been doing is that obviously for anything to do in our world, we need the physical hardware and infrastructure. And what it intends to is you need basic compute, storage, and infrastructure to run anything that you're trying to do. That is, no brainer here. We all know that. On top of this physical hardware and infrastructure, we have a host operating system here, which could be anything, a Windows operating system or a Linux operating system. And when we go into the virtualization area, then we need a hypervisor to run our virtual machines on top of it. That hypervisor could be, for an example, a VMware or Hyper-V from Microsoft, or any hypervisor from Citrix, or a out of kind of a OTC kind of a hypervisor, commonly OpenStack hypervisor. So whatever the case may be, and then we deploy the virtual machines. Virtual machines are going to run the guest operating system. So we have a host operating system, and then we have the guest operating system. And guest operating system could be anything, could be a Linux flavor or could be a Windows flavor. But on the guest operating system, we are running the guest operating system kernel, certain libraries, and on the libraries, applications are consuming those applications and running hundreds and hundreds of processes there. And this is what we know. This is what we are all very familiar with it. I don't need to go deeper into that. But when we move from a virtual machine approach to a containerized application approach, there is a monumental shift in the architecture. So obviously, the common component here is physical hardware and infrastructure, which is what we talked about. Then you have the host operating system, which is also common. This host operating system could be again Windows and Linux. Now, especially when we go from the containers perspective, this host operating systems, when we're talking about cloud and AKS, which is our focus area today, this is also managed and maintained by the cloud provider. So we really don't need to worry about this host operating system from our perspective, and we will dig into a little bit deeper once we go down in our slides and actual demo. And what happens here is, in the containers approach, instead of using a hypervisor, we use the runtime, which is a container engine, which allows the containers to communicate and leverage resources from host operating system. So basically what's happening here is the host operating system is shared between different containers, and each container is running in its own space, right? So they're independent of another container, and that brings the concept that we're going to talk about of microservices momentarily. But this is a difference between a traditional virtual machine approach and containerized application approach. The key differentiator that you would notice here is that in containerized application, there are no virtual machines, right? Rather, they have been replaced by containers. That's very important because that would make a paradigm shift in terms of application development. But unless we talk about that, what additional feature it brings into, what advantages it offers, the purpose of this slide would be defeated. So let's dive into that. What we accomplish using a containerized approach versus a traditional virtual machine approach. So let's go back into the virtual machine side. And let's look into what we are doing in virtual machines. So basically, you have, as I mentioned, you have a guest operating system kernel, you have libraries, and you have got application. But we deploy this virtual machine for hosting an application. But the fact of the matter is that application is the services or the processes that application requires to run may require a very little compute in terms of memory, in terms of processor, or in terms of storage, as well as in terms of network, right? Now, for an example, that process or those processes required to run that application may only need 20 MB or maybe 40 MB or maybe 100 MB of RAM and very minimal processing, very minimal storage, very minimal networking. But because we have a dependency on guest operating system, which is running other hundreds of processes, that virtual machine is now configured with 4 gig of RAM, 4 vCPUs, right? A 200 or 250 gig of hard drive, whatnot, networking component. So if you look carefully, when we move into the containerized application, that's a shift because we are not optimally using the resources here, the hardware resources in the virtual machine strategy. So what happens, instead of using the virtual machine, and when we talk about container, we only use the process that leverages the library. And the base operating system, which is what is in the virtual machine, is a separate guest operating system, is being leveraged by the shared host operating system. So when we look into the resource utilization, compute utilization in terms of containers, it is significantly reduced from a virtual machine perspective. Instead of running the 4 gig virtual machine, this container is now only using 20 MB or 400 MB or 100 MB of your memory, which allows you to optimize your resources as far as the hardware is concerned, and which is a tremendous shift in terms of the DevOps and modern software engineering. Not only that, right? This is very important to understand again, because when we talk about microservices, so traditionally when you're running an application, multiple processes are running on the same VM. Now, when we go with this segmented approach and application segmentation with microservices, you can divide that application into multiple segments as part of microservices architecture, and they run in their own space, in own containers, independent of each other. So if you need to fix anything, change anything, you just modify that piece instead of worrying about rewriting the whole code all over again, right? And that brings the agility, that brings the required speed, that brings the DevOps process so effective. And that's why more and more organizations are leaning towards a container approach when we are talking about deploying a modern application, right? Furthermore, when we are talking about application development, DevOps cycle, modern software engineering, one of the other challenge and the nightmare for the developers is the dependencies on the operating system if we are going with a virtual machine approach. What I intend to say is that a developer writes a particular code or an application on one platform or one OS, and when it finally goes and delivers in production, it might not work the same as it has been working on the developer's desktop because the operating system has changed, right? And think about another situation where you have to update an operating system, or you have to move the operating system, or you have to move the application. That's just a nightmare because from the developer perspective, you have to rewrite the code, make sure all the required adjustments so that the application, your existing application, can run on a newer platform, right? But once you go with the containerized technology, that becomes a seamless process, because as you see here, you only need to worry about those binaries that or those libraries that you are using, and it doesn't really matter at that point. So that brings a lot of agility, that brings the DevOps process so efficient and effective. So not only you are seeing the advantage from the compute perspective, but from a totally from the ease of developing an application, portability of an application, the containerized approach provides you a lot of definite advantages, right? So that also makes it so popular, because everybody would like that we don't have to worry about the base OS dependencies anymore, because we're not really worried about it. So that's another advantage to keep in mind when we are talking about and comparing the approaches between a virtual machine and containerized application approach.
So another way of understanding the container could be an analogy. Consider each container as a sandbox that is running certain processes to run that application, and importantly, without the operating system kernel here, right? So it's just running certain libraries to run the application, and you can just conceive it as, just to have a better understanding of containers, that it's kind of a sandbox, right? I hope it makes sense, right?
Having said that, you also have understood here that instead of maintaining several hundred VMs, maybe in your data center you have got 500 VMs hosting different applications. Now imagine that now you need to manage 500 VMs from the OS perspective, from patching perspective, from the antivirus perspective, the backup perspective, and don't forget about the high availability as well, right? So if you have to have a high availability in DR, the same virtual machine that is hosting app A would be multiplied into 2 or 3 or 4 and different geographical location, different backups. So this is a very complex situation, right? So app A may be running on 4 VMs, and then you are running a load balancer behind it. Now think about it, that what the impact is in terms of an organization overhead, the management overhead, the cost overhead. It is significantly higher. I would say it's so different when we go into the container applications, that's the reason that organizations are leaning to the container approach, right? Now, not only that, no matter what your application is doing in the virtual machine approach, you're still consuming your resources for that virtual machine, right? So if the virtual machine is using, let's say, 2 gig memory or 2 gig or 3 gig of RAM, because even if the application is not running or not utilizing it, you still need to run that 3 gig RAM on that virtual machine. So your utilization of physical hardware as you go forward and keep adding those virtual machines becomes difficult, and you have got less and less resources available from the hardware perspective. On the contrary, when we go into the containerized application, what happens here is that if that application is not, if that container is not being used, if that application is not consuming that application, it releases the computing resource so that the other containers can use it. And that is pretty interesting. That's pretty cool. Basically, we are further optimizing the resource utilization from the hardware perspective, which make more sense to use containers. On top of it, each container is running and is independent of another container, right? So from microservices perspective, as I mentioned earlier, whatever you need to update, you just need to update a tiny portion of your code or your process here. And instead of worrying about rewriting and testing it and this, that, you could do it on the fly, test it, and you are up and running. So that agility that we are talking about of DevOps process or modern software engineering goes hand in hand with this approach. Not only the compute optimization, but the overarching microservices architecture, the overarching independent processes running into each container makes it more susceptible to be adopted by your development team, right? And that is pretty interesting. Now, these are all good points here, right? This makes your head say, yeah, it makes sense. It makes sense that that organizations are leveraging and going in the direction of using containerized application. But there are always two sides of coin, right? Now, the other side of the coin is that what are the challenges? What are the disadvantages? Because we have a shared host operating system, which is, hosting different containers or different pods that we will talk in next slide, then it becomes a little bit more complex to deploy a container application. It's not like a virtual machine where you deploy the virtual machine, you install the application, and you're good to go. Here you need to think and consider about different dependencies between containers or pods, the namespaces, the networking customization between each app, the backend storage that is being leveraged from your host operating system, from the volume perspective, what application uses so that you don't override one data set by another container. So there are a lot of consideration that you have to put into when you design this container approach. So it's not very straightforward as it is in the case of virtual machine. Here's a lot of moving pieces that you have to plan and design appropriately to have the desired results of your application deployment process, right? And again, the host operating system here, one of the advantage or disadvantage both way, right? The host operating system is a shared host operating system. So generally, the intruders should not be able to get to the host operating system. And as a result, the surface area for attack is reduced from the host operating perspective. In a VMware, the surface attack area in the virtual machine is very large because you have got 500 VMs. Each of them is susceptible for attacks, plus your host operating system. That is not the case here in the containerized application. Obviously, one of the key consideration here when you are planning the containers, that the host operating system is optimized and customized for containers. You don't want to run a full-blown OS to run your container because that defeats the purpose and that brings the vulnerability in your operating system and in your container strategy. So that's also important when we are designing the containers here, that the host operating system as well as the runtime, which is the container engine, is optimized only for that process. Because if somehow a container compromises or container passes something vulnerable or malware to your host operating system, not only you impact that container, but you impact every single container running on that node, right? So from security perspective, from attack perspective, when we design the containers, it is absolutely important that we keep the best possible recommendations. And I would be creating another presentation that would talk about the challenges and the remediation when we talk about containers, including security, including performance, that what are those key components that we should be considering when we are going for containerized application. I can't do it in this presentation. That would be too long and nobody would watch it. So wait for that presentation to be published, hopefully in next few weeks. But I think this slide and whatever we have talked so far make a lot of sense. We have a general idea of the difference between a traditional virtual machine approach, a microservices that we're talking, where you segment your application, and taking the advantage and deploying those microservices through containerized application approach, right? Now with that, let's go a little bit more deeper and try to understand the different acronyms, different processes that are being used in container technology. So you might have heard the word like images and microservices. We talked about the registry, the containers, the pod, right, the engines. Let's try to understand all this, that how do they work together, right? So first, let's talk about the images. So images are basically the binary files, and images are the one which are actually deploying the containers on your container cluster, right? Very straightforward. Now, if you really want to put an analogy here, I would say consider container images as a VMDK or VHD or VHDK file, which you use to deploy a virtual machine. Obviously, it doesn't have the OS kernel part of it, right? And it has been very systematically and plannedly, there's a hierarchical structure that you have in the images, so that instead of, when you need to run something or modify something, instead of modifying everything and writing the code all over again, you can hit the specific piece or specific section because of this hierarchical structure that you have in the image files. These image files could be Docker image files or a Cloud Foundry. So it could be different by the different providers, but fundamentals are the same, and it allows the required agility in terms of the development process that, hey, I need to modify only this section of the code, and go ahead and do that. If you need to modify something else, you just modify that piece. So the whole agility and the CI/CD becomes real when we are using these images, right? So that's very simple. Again, it's not exactly a VMDK or VHDK, but if you try to understand in your brain from the infrastructure perspective, because we all come from that background, it is something very similar. Obviously, this is much smaller than a VMDK or VHD, but I think you get it, right? Now, the container images are deploying the containers on the host cluster, but there is an intermediate, which is the registry, the container registry. Container registry is considered as a repository of your images. So all those required images that you have created from microservices perspective or different applications perspective are stored in the container registry. From the container registry, they could be pushed or they could be pulled into the host cluster, where you would deploy the containers, you would configure the pods, right? I think that makes a lot of sense now. It's so easy and simple to understand. Initially when I didn't know what the containers are, I was having a hard time to understand this very simple concept. I hope I have made it clear, right? You also understood the microservices part, where a traditional application is broken down into multiple segments based on different process and different components. So that also goes in alignment of the modern software engineering. And we already talked about, and I think this slide explains it a little better, that the container engine or the runtime is the one that allows a container to talk back to the host cluster, right? Utilize all the resources to use the base OS kernel from that perspective, and just use the libraries into the container to run the application. So instead of running the whole kernel here, the kernel is shared between different containers, and how do you access that is through the container engine, whether it is a distribution, orchestration, or the data volumes that you're going to access or write the data or read the data from your host cluster. Your container, your build kits, and your networking is all being delivered and managed through container engine, which could be Docker, which could be something else, depending on what kind of a container engine we will be using. I'll be showing you in the next slide. You also have the container API, so that the different APIs can consume the application that you're creating on your in your containers or the host cluster. You also have the container CLI, and then you have the plugins. Now, this is interesting, the third-party plugins. So imagine that if you have a requirement for your application to talk to another Python application, you're running a Node.js application on your VM. Traditionally, with the virtual machine approach, you would end up creating more virtual machines for that third-party application. So you would have another machine running a Python application or script, right? And then you would work them and connect them together. So it's much more complex. It starts going and talking about more resource utilization. You deplete the hardware resources from virtual machine strategy. But with the plugins available, you can have one more container and you can just connect to that service, the third-party service, very effectively. Right? So let's talk about pods and containers. As I mentioned earlier, that pods are the repository of containers. But let's try to understand one more logic behind it, right? So basically, when we deploy these images through the container registry into a AKS cluster, that YAML file has all the required configuration. But the interesting thing to note here is, say for an example, if your YAML file the file, the manifest file that you are gonna use to push these images from container registry to the AKS cluster, you create just one replica of that particular image, then it would create one pod, and it would have that container inside that pod, right? Now, hypothetically, if you decide to use, hey, I'm going to create 3 different replicas of that image, right? Then automatically it would create 3 different pods for that, and each pod would have one of that image sitting in that, right? I hope that explains you. So pod and containers have a direct relationship. Obviously, you could create, other web app applications or something into the same pod, but that defeats the whole purpose. But the relationship here between pod and container is dependent on basically how many replicas of that container or that container or that image that you need to push into the cluster, right? And that's how you have, if you have one replica, you will have one pod. If you have 2 replicas, then you might have 2 pods, and depending on how you go further. So that probably explains it. And same way, in the same file, the manifest file, the YAML file, you also define the required namespace. There are several other settings that we can do, right, in terms of when you do that, whether we will be using a cluster IP or the node IP when we start talking about external networking. And those are advanced stuff that I don't want to cover here in this presentation because that's going to confuse you furthermore. So this is interesting. This makes a lot of sense to me, at least. I don't know how you react to this, and your feedback would tell me whether my way of presenting makes sense or not. But from my perspective, I get it. I really get it, right? So container images are the ones which are deploying the containers. You store them into the registry. You push and pull from there. The microservices part is your DevOps process and the development team who would divide and segment this application. Your container runtime or engine would do all the required connectivity and resource utilization from the host OS. How simple that could be. I think this is pretty amazing. This is pretty cool. Now, once we have understood this high-level container technology, let's dive into the AKS. Now, before we even talk about AKS, let's take a step back and talk about ACS, which stands for Azure Container Services. So when Microsoft initially came with the container features in Azure, they just came with ACS, which is Azure Container Services. And what it means is that Microsoft Azure would provide you all the required infrastructure to deploy your containers, but then you are at your own. That means all the design, configuration, deployment, this is all your problem, right? So you manage that container services at your own. And that could be very demanding in terms of design, deployment process. It could be very time consuming. And actually speaking, it defeats the whole purpose of the modern software engineering, the agility, the speed that we are talking about, right? So you can call ACS as an unmanaged container services. So then comes the Kubernetes. Now, Kubernetes is not specific to Azure. Almost every single provider is using the same Kubernetes code, whether it's Azure, whether it is Google, or whether it is IBM, or whether it is AWS, or whatever the case may be. So base code remains the same. What we are getting with AKS is a managed Kubernetes services or Kubernetes API to manage your Kubernetes clusters. So instead of you doing all the hard work of manually configuring that, as in the case of ACS we discussed, now this is all managed through AKS. It makes your life, our life simple because all the responsibility of that overhead, of that control plane of your containers is now handled by Kubernetes, right? So, I mean, for the lack of better words, would it make sense to say that AKS is your managed ACS, right? That's what pretty much it boils down to. You don't need to worry about all those features. You have simple command line syntaxes that you could use, and leave rest of the stuff to be managed by Microsoft as platform as a service, right? So it provides you a lot of features and benefits. When we talk about platform as a service, obviously it comes with self-healing, but it intends to that if your node is having a problem in that cluster, you don't really need to worry. This is Azure Platform Service automatically going to take care of it. So that headache of maintaining and managing that is gone, right? Now, the upgrade, right? Upgrading a cluster from the AKS perspective could be very time consuming, could be very difficult, could be painful if you do it manually. What Microsoft said, okay, we're going to make it transparent for you. You just run and upgrade your cluster running one single command line. And here you go. It is automatically going to take care of your master nodes and worker nodes. You really don't need to worry about transitioning application. Doing all that stuff is automatically being taken care by the Azure Platform as a Service, right? It makes a lot of sense. And as I mentioned, the Kubernetes is using the same upstream code as by any other provider, so the standard remains same. It makes the developer's life easier because you're using the same thing that you have been using if you are at all using other providers. Obviously, there is no VM management here, right? So first of all, there is no guest operating system or guest VM running in the container side. So the only VMs that you have is the VMs used by the cluster nodes, and which again is not your responsibility because that is Microsoft's responsibility as they are offering it the platform as a service. So that overhead also goes from your head or from your organization head. Talking about security, TLS or transport layer security is everywhere. And because Azure uses Key Vault, so you have that ability to back it up in Azure Key Vault, right? Now, because of so many moving pieces, monitoring of your cluster instances or AKS cluster is extremely important. And because Azure has this powerful Azure Monitor or log analytics that we have been using, obviously AKS integrates with Azure Monitor so that you have the same common interface that that you have been accustomed to in terms of your monitoring capabilities, which makes the solution more acceptable from the administration and management side. I think all of us are also very familiar with RBAC, role-based access control, and Azure AD integration. Obviously, AKS is integrated into Azure AD, and you can take the full advantage of role-based access control. Once we get into the demo, I would be able to show you the different roles that are available, especially in terms of managing and maintaining the container registry. And you could do other roles as well through your regular RBAC tool that you have available in Azure. It uses by default the solid state drives for your nodes, so that guarantees you the highest IOPS in terms of your disk writes and reads. So that is another advantage. And as far as the Kubernetes control plane is concerned, that's for free because you only pay for the services for the containers. So that is also very attractive. Now, SLAs is always a concern for organization, and you are assured of 99.995% assurance with AKS, which is pretty impressive. You don't need to worry about high availability and backups because that comes automatically when you deploy the AKS clusters, right? So you don't have to worry about that. So that's a huge advantage and feature set that makes you use containers or AKS more frequently. And obviously, as I mentioned earlier, that networking is an important part of the architecture of AKS, depending on what you're doing, dependencies, when you're talking about different containers or pod and namespaces and connecting them. So that's where you have very customizable networking option available in AKS too, right? You can also use at a higher level to VNet, and you have applications gateway configured. You can have the WAF configured in front of it. So a lot of other security benefits that possibly I would address in another presentation around Azure Kubernetes Services, security, compliance, and governance. With that, once we have a good understanding of the containers and AKS, let's just start looking to who are our different providers at the different layers of pyramid. And when we look at the pyramid here, the base which we have talked about is the physical infrastructure, which could be a compute, the storage, and the networking part, right? So compute, storage, and networking. And then the virtual infrastructure, the hypervisor, which could be VMware, which could be AWS, which could be Google. And in our focus area today is Microsoft Azure, or it could be an OpenStack, but our presentation is all around Microsoft Azure, so we'll focus around it. Then we go into the operating system, which would be running the hosts and the containers here. And the different operating systems that offers the container services are Linux-based operating system, which are most popular and common. And Windows Server 2016 is a new entry into this field and is also slowly and steadily gaining momentum there too. But primarily, as of now, for our discussion, our presentation perspective, that would be a Linux-based operating system. We talked about container engine or the runtime earlier. There are different providers, there are multiple of them, but the most common is Docker that we are going to leverage in our presentation and our demo today. There are others, RKT, LXD. Frankly speaking, I have zero idea about it, so I'm not going to even talk about it. Clustering and scheduling, again, our focus area is Kubernetes. There are other providers which I'm not too worried about it at this time because, honestly speaking, as I mentioned, I'm new and I don't even know the advantages and disadvantages of other clustering and schedulers here, right? Orchestration, same story. Our focus here is Kubernetes. There could be other providers and we're not going to worry about them, at least for today's presentation. Same is the workflow here, AppShare, Docker data centers, ranches. There could be Jenkins and other CI/CD process that you could leverage for deploying your applications into containers, right? So I think now we have a solid understanding. I would not say that we have a very deep understanding, but at least from a beginner perspective, we know what the containers are, we know what the AKS is, we know who are the different providers at the different layers of the pyramid, and that gives us a good understanding to jump into our live demo. And that would be another presentation, another video that I request you to watch. If you like this, please provide me your feedback, whether you like it or you dislike it. Your feedback is the one that keeps me encouraged to create these videos, because as I said, that's the only motivator that I have, right? So please do provide your feedback. Thank you again very, very much. And hopefully you would also watch the live demo, which would make sense to all what we have talked so far. Have a blessed day.